Hello and welcome back to AWS with a Beer and to Domain 3, Applications of Foundation Models of the AWS AI Practitioner. Now if you missed Domains 1 and 2, then you can find links to these videos in the comments below. Before we get right into the details of the exam guide, please like and subscribe so you don't miss out on more AWS Cert content. So the first task statement will ask you to describe design considerations for applications that use foundation models. So you need to have a high-level understanding of how to best apply them in real-world scenarios. Imagine being an AI architect faced with a vast array of pre-trained models. Some are fast and cost-effective, others are highly complex but deliver more nuanced outputs. The exam may test your ability to evaluate models based on criteria like cost, modality, such as text and image, etc., latency, and whether the model can handle multiple languages. You'll also need to consider how model responses can be tweaked using inference parameters like temperature, which can control how creative or deterministic the output is, or the length of the input and output, which affects everything from processing time to accuracy. A key concept you'll need to grasp is retrieval augmented generation, or RAG. This is where AI gets a boost by pulling in additional information from a knowledge base in real time to improve its answers. Expect to see scenarios around using Amazon Bedrock for business applications, where RAG can enhance chatbots or customer service solutions by pulling in the latest information from a company's database. Now, the exam may also dive into storage options for embeddings, those dense information-packed vectors that power everything from recommendations to semantic search. You'll need to know which AWS services are best suited for storing these vectors, whether it's Amazon OpenSearch Service or Amazon Neptune for graph-based storage, or even DocumentDB. Cost is also a concern in AI projects as well. So you'll be asked to weigh the trade-offs between methods like fine-tuning versus in-context learning or even pre-training from scratch. Should you invest in fully fine-tuning a model to get a perfect fit for your use case, or go the cheaper route with in-context learning, where the model adapts on the fly with just a few examples? Now lastly, be ready to explore how agents, like those that we can find in Amazon Bedrock, can automate multi-step tasks. Picture an AI system that not only understands a customer's request, but also knows how to fetch data, perform a task, and report back, all autonomously. This is the kind of practical, real-world AI design the exam will challenge you to master. The second task statement focuses on prompt engineering, and it's a crucial skill in the world of AI, and also the AI practitioner exam will likely assess your understanding of the best techniques to optimize outputs. Imagine prompt engineering as the art of crafting the right questions or instructions to coax the best possible responses from AI. You'll need to know what goes into crafting effective prompts, such as setting the right context or giving clear instructions. You'll also want to recognize negative prompts, which help steer responses away from unwanted directions, and understand how the model's latent space, its vast knowledge base, is utilized during generation. Expect to see questions related to popular techniques like chain of thought prompting, which involves guiding the AI through step-by-step reasoning. There's also zero shot, where the AI is asked to perform a task without any examples, versus few shot and single shot methods, where you provide one or a few examples to help nudge the model in the right direction. You might also need to work with prompt templates, predefined structures that boost consistency across multiple queries. To succeed, you'll have to understand the benefits of prompt engineering, improving response quality, experimenting with phrasing to see what works best, and setting up guardrails to ensure outputs are on track. Best practices emphasize specificity, conciseness, and even trying multiple variations of prompts to refine results. But with great power comes great responsibility. So you'll also be assessed on the risks. What happens if someone jailbreaks a model to get it to say harmful things? Or if a prompt is subtly poisoned to influence outcomes? Knowing these risks, like exposure to biased content or prompt hijacking, is just as important as mastering the positive techniques. So in short, this section covers everything from crafting effective questions to safeguarding against potential AI misbehavior, ensuring you're equipped to get the best and safest results from today's powerful models. You might see scenario-based questions where you choose the best prompt style to solve a specific problem or identify the right safeguards to implement in a hypothetical AI project. Now, the third task statement requires you to describe the training and fine-tuning processes for foundation models. Those massive pre-trained models like GPT are trained and fine-tuned. This isn't just about tweaking a few parameters, but involves grasping the full journey from initial training to making a model really shine for a specific task. First up, you'll need to know the building blocks of training a foundation model. This means understanding pre-training, where a model is trained on a vast dataset. Think of it like teaching a toddler every word in the dictionary. And then fine-tuning, where that model is specialized for a specific task, like teaching that toddler to write poetry. You might also encounter continuous pre-training, where the model keeps learning new things over time and stays sharp. The exam could throw scenarios at you that ask how you'd fine-tune a model using techniques like instruction tuning, where you teach the model to follow specific commands better, or domain adaptation, such as making it a pro at healthcare lingo instead of legal jargon. Transfer learning will also pop up, where the knowledge from one task is applied to another, much like how learning to ride a bike helps you to ride a skateboard. Another big piece is data preparation, which is crucial for fine-tuning. Here you'll be expected to know about curating the right dataset, ensuring it's clean, labelled correctly, and representative of what the model will encounter in real-world use. Data governance matters too, so understanding the ethical and legal guidelines for using data is a must. You'll also want to know about techniques like reinforcement, learning from human feedback, where human inputs help steer the model towards better outputs. Imagine training a robot chef to give feedback until it stops putting pineapple on every pizza. So, expect questions to blend the technical with the practical, like how you'd create a dataset for a model that will help with medical diagnoses, or best fine-tuning method for a voice assistant. By mastering these elements, you'll be able to confidently tackle any scenario the exam throws at you, whether it's choosing the right pre-training method or figuring out how to make a model learn like a pro. The last task statement asks you to be able to describe methods to evaluate foundation model performance. So here you need to dive into the metrics and methods that ensure these powerful models do more than just look fancy. They need to deliver results. You'll explore how to assess a model's effectiveness with approaches like human evaluation, where actual people give feedback on the output, and benchmark datasets, which provide standardized tests that measure how well the model performs compared to others. But it doesn't just stop there. You'll need to be familiar with metrics like Rogue, Blue, and BERT score. Now, these acronyms might sound like some kind of robot lingo, but they're essential for understanding how closely a model's output matches the desired results. Whether it's summarizing text, translating languages, or generating content, in the exam, you may encounter scenarios where you have to decide whether a foundation model is hitting the mark for business objectives like boosting productivity or enhancing user engagement. For instance, you might be asked to determine if a chatbot's responses are leading to better customer satisfaction, or if a language model is helping automate tedious tasks efficiently. The key is understanding how these evaluation methods and metrics tie back to real-world goals, because a model is only as good as the value it brings to the table. So if you want to ace this section, think of yourself as a performance analyst with a dash of AI wizardry, balancing technical precision with business impact. So that's domain 3 now covered, and so when you're ready, take a look at my video covering domain 4, guidelines for responsible AI. Please like and subscribe so you don't miss out on more AWS content to help you ace your certs. Cheers.